the previous lecture, we started to work here on Microsoft Azure Machine Learning Studio. And what we started to do was to import some data that I had on a CSV file, on a couple of CSV files. And once we imported them, we were able to add them very easily here as the datasets that we are going to be using in this loan information experiment. Now, because eventually I needed these two CSV files to become one single dataset, what I did is import another module that is called join data and define through the properties how is it that these two datasets were going to be joined together. So now if we take a look at our join data dataset, we're going to see that it contains all of the information that we had. Now, there are a couple of things that you should consider when you have your data. The first one is whether your data is in the correct format, and the second one is whether some of those elements that you have could be normalized. So this is of course going to be dependent on the type of data that you have, but there may be some scenarios where maybe certain value must be normalized by maybe raising it to the second power. So basically squaring the values so they have a better fit into your overall data. In this particular example that we have, I did identify that maybe these three last elements may not be in the correct format. What I'm going to do is define that education, gender, and loan status are categories. Because you can definitely see how for education there are only 4 elements, for example. This is definitely not a numeric value. That if I were to enter education, I would be able to enter an infinite array of values. This is simply 4 values. For gender, it is 4 values. This is limited to male and female. Loan status is limited to paid off, default, or collection. So definitely something to work in here, because eventually we're going to be trying to predict the status, the loan status after giving certain information. And loan status cannot return a value, for example, between 0 and 100 or 0 and 1. It will have to return one of these categories. So to be able to do that, I am going to search instead of data transformation again, in manipulation, one module that is called edit metadata. And of course, I'm going to establish that line, that relationship between the join data output, which is of course the entire dataset now, and this new module. Of course, we will have to establish some information here in the properties. The first thing is to select to which columns do we want to modify the metadata. And like I said, I'm going to define education, gender, and loan status. I'm going to hit on OK. And the next thing that I have to do is establish what is it that I'm going to change. So as you can see, I could change the data type. I could change to string, integer, floating point, boolean, datetime, and time span. The one that I'm interested on right now is the categorical. I am going to select make categorical. All of these 3 columns are now going to be considered categories. In this same section, I could also change the fields. So whether these are features, labels, weight, clear feature, etc. We are not going to be modifying anything here. This is going to remain unchanged. Notice that we could also define new column values. Again, not something we're going to do. This is everything that we have to do for our metadata. Again, we will have to run this module. So this is applied. So I will navigate to run. And because the previous modules are already completed, I don't need to rerun everything. In fact, I still see this green tick over here. So when I navigate to the run button, I can simply run the selected element. If any other elements before this one weren't ready, they would be run again for this one to be able to run. But that is something that we can do to save ourselves a few seconds, because we don't need to run everything again. And so now our metadata is going to have those categories, but there is another thing that I want to do in here. If we visualize our data, you will see that those values that are numerical really have values that are very different. We have, for example, the principal that can go up to 1,000, when the terms really go only up to 30. And even in past due dates, most of them are in 0. And there is also age that has kind of like a normal distribution in here, but also is quite different to, for example, the principal. My point here is that eventually if a model sees a 1,000 value in the principal, it may assign a higher weight or a bigger weight to that value than, for example, a past due days of 0, when it might not be the case, because there's no reason why principal may have a higher weight than terms, but because this is in the thousands or in the hundreds at least, and this is in the tens, and the same for the age, it may think that principal should have a bigger weight. So what we are going to do is normalize this data. And I recommend here that you use a couple of different ways of normalization. The first one that we're going to apply is to those columns that don't have a normal distribution, like the age does. So past due days, terms, and principal are the 3 columns that are numerical that do not have a normal distribution. When we see them graphed in here, we don't see any bell shape as we kind of see here in the age column. So what I'm going to do is, after editing the metadata, I am going to add another module that is also in data transformation, but this time inside of scale and reduce. This one is the Normalize Data module. I am going to connect it to the output of my edit metadata module, and here I will have to do that transformation. For these columns, in this Normalized Data module, I am going to select the columns. In fact, let me go ahead and do so now. I am going to select the columns that are numerical that are not normal. They don't have a normal distribution. And notice that by default, it is already selecting those columns that are numerical. I see principal, terms, past due dates, and age. And precisely I need these except for the age, because age I'm going to be normalizing it in a different way. So I will select only these 3 columns, hit on OK, and these 3 columns are not in a normal distribution. I will do the min-max transformation method. As you can see, there are many transformation methods that you can apply for these values in particular, because they are not normally distributed. I am going to select min-max. And then I have to do the exact same thing, but with the age column. Now notice that the Normalized Data module has 2 outputs. And if we hover over them, we see that the first one is a transformed dataset. This is the one that we need. The other one is simply the transformation function. We really don't need the transformation function. So I will continue to use this one. I will not run this module yet. Let me add another Normalized Data module. And what I will do is, from the first output of the first Normalized Data module, drag over to this new Normalized Data module. In this one, I am going to be using z-score, which is a better transformation method when it comes to data that is or that has a normal distribution. And in the selected columns, I am going to be selecting to include by column names. I am going to select the age column. Now I want you to notice something quite quickly in here. I am using the with rules element in here, not the by name, mainly because by name is actually not available. Because I haven't run the experiment, I cannot use this tab, but I can do so by rules, click on OK, And now I will have the exact same result. Now what I can do before moving forward is to run this selected module. Now notice, because I have a selected module that is after other modules that I haven't ran, when I select run selected, all of the previous modules that are not yet ready are also going to be selected. So when I hit on run selected, these two modules are going to run. Once this is ready, we will be able to see the output of the second Normalize Data module. If we see it, we can now identify that principal, terms, past due dates, and age are now normalized. Notice that, for example, if we select the principal, the values go from 0 to 1. And they will still pretty much have the same value, except it now goes from 0 to 1. We see that if the principal was 0, we see a 0. If it was maybe about 700, we see 0.7. Most of them, if you remember, were 1,000, so we see 1, maybe it was the highest value, so it's the one that is set to 1. When it comes to terms, again, we're going to see those that had the highest value are set to 1, and from there they are normalized, for example, to 0.34, which is the case for many of them. And the same thing will happen with past due dates. Most of them are going to be in 0, you remember. Some of them that are not paid off have been pushed all the way over here close to the 1. And with age, that is the one that we are normalizing differently with a z-score value. We see that it goes from minus 2.2 to about 3.3. So now our data is going to have more similar values. There isn't going to be a huge difference between the principal of 1,000 and the term of 30, for example. Now there is one more thing that I want to do in here. There are many columns in here that are not really going to help the model eventually make better predictions. For example, the loan ID has absolutely nothing to do with how well someone is going to pay or fail to pay a loan. In fact, it is going to be unique for each and every one of the entries of this table. So we should really remove this or simply not consider this when building the model. And the same thing for effective date, due date, and paid off time. So these three columns that are date times are really not that important once we have the past due days. Whether they requested the loan 2 years ago or 1 year ago or 10 years ago, it is not going to be as important as knowing how long it took them after the due date to pay their loans. And finally, we should remove really the loan status, or at least not consider it when building the model, simply because this is what we are trying to predict. We don't want this to be a feature of the model, we want to predict this. So we shouldn't be using this to create a model. What I'm going to do to filter that out is, again, from manipulation, from data transformation, edit the metadata. Connect the first output of the second normalized data module to this new edit metadata, and I'm going to select some of the columns. We'll start by selecting the loan ID, the due date, the paid off time, and the past due days. I'm going to click on OK, and these elements are not going to be features. So from fields, going to clear the features. So these are no longer going to have the feature label. They are not going to be considered features. I'm clearing these fields from that label because they are not going to add any value to my model. In fact, if they were considered features, it may just break my model because that data, especially the loan ID, make no sense. They are always different. So these really should not be considered features. And now let me do the same thing with another edit metadata, but for the loan status. So because that is going to be the output, let me first select this column, and because I haven't run this, I have to do it here with rules. So I will select loan status. So this column is the output that I want, which means that it is not going to be a feature, it is going to be a label. So here in fields, I am going to select label. And so I will be able to run these two new modules. With all of these modules that we have added throughout this lecture, we have manipulated the data in the way that is going to allow us to better create our model. The model is now going to be normalized. Our data is normalized. We have edited the metadata so it works the way it's supposed to work. We removed features, we assigned labels, etc. That means that we are ready to start defining how the model is going to work. So starting in the next lecture, we're going to first talk about what type of machine learning we're going to be implementing here, what technique we're going to be using, and how is it that we're going to be doing it directly here, of course, from the Machine Learning Studio. So now that our data is ready, in the next lecture, we're going to configure the model.